Welcome to a vision of the future that could redefine space travel forever. What if I told you that reaching Mars could be as easy as stepping onto a high-speed train? Imagine a highway in space, where spacecraft glide effortlessly toward the red planet, free from the limitations of chemical rockets. No more massive fuel tanks, no more 6-month journeys, no more unnecessary risks. Instead, we harness the power of magnetic acceleration, a revolutionary concept that could cut travel time to Mars from months to mere weeks. This is not science fiction. It's an idea rooted in real physics, inspired by cutting-edge advancements in electromagnetic propulsion. Join us as we explore the Magnetic Highway to Mars, MHM, a bold concept that could change the way humanity conquers space. The harsh reality of space travel. Traveling to Mars with today's technology is like setting off on a perilous sea voyage centuries ago. Slow, dangerous, and uncertain. Spacecraft rely on chemical propulsion, requiring massive fuel tanks that limit payload capacity and increase mission costs. Astronauts endure long-duration space travel, exposing them to cosmic radiation, microgravity effects, and psychological stress. Every mission is a one-time use, requiring a new rocket and an immense amount of resources. We need a game-changing technology that can send humans and cargo to Mars faster, cheaper, and more efficiently. The cost of chemical rockets. Imagine launching a rocket from Earth, each launch costing hundreds of millions of dollars. Chemical rockets burn through thousands of tons of fuel, yet their efficiency is still low. The more fuel we carry, the heavier the spacecraft, requiring even more fuel just to lift off, an endless cycle of inefficiency. This forces engineers to make painful trade-offs, carry less cargo, fewer people, or take longer to arrive. The long, dangerous journey. A standard Mars mission lasts between 6 to 9 months, meaning astronauts are stuck in deep space for an incredibly long time. Prolonged exposure to cosmic radiation increases cancer risks and could even damage the brain. Microgravity weakens muscles and bones, meaning astronauts might not even be able to stand once they land on Mars. Then there's the psychological factor: isolation, cramped quarters, and no real-time communication with Earth. The fragile nature of space travel. Any technical failure, whether it's life support, radiation shielding, or trajectory miscalculations, can turn a Mars mission into a death sentence. Unlike the Moon, which is just 3 days away, Mars is so far that an emergency return is impossible. Once you launch, you're committed, there's no turning back. This forces us to rethink space travel. What if we could get there faster, safer, and with much less fuel? That's where the Magnetic Highway to Mars comes in. Imagine stepping into a spacecraft not burdened by hundreds of tons of rocket fuel. Instead, you are riding a wave of invisible energy, magnetic acceleration, reaching unimaginable speeds across the vastness of space. This Magnetic Highway to Mars, MHM, would redefine how we think about space travel, creating a transportation network powered not by rockets, but by electromagnetic force. It's a monumental shift, one that could enable us to travel to Mars in a fraction of the time we know today. The Magnetic Highway isn't just a dream. It's a complex engineering marvel, involving a series of massive electromagnetic rings stretching from Earth's orbit all the way to Mars. Think of it as the largest maglev system in the universe, with spacecraft accelerating smoothly as they pass through each ring. The first ring would propel the spacecraft just a little bit. The next one would give it another boost, gradually accelerating the craft with carefully synchronized magnetic pulses, like a roller coaster building speed. By the time you're halfway to Mars, you're already traveling at speeds that would take traditional rockets months to reach. By the time you get close to Mars, you're not just a visitor. You're a carefully timed traveler with speed and trajectory finely tuned for a smooth, precise arrival. Gone are the days of risky launches and slow burns. Now, space travel is streamlined, efficient, and cost-effective. The Magnetic Highway would make missions more reliable. No more one-time use rockets or skyrocketing fuel prices. We can use the same rings over and over, making each journey cheaper and more sustainable. More frequent travel to Mars means more missions, more cargo, and most importantly, more opportunities for humanity to reach beyond our planet. Launch and entry. The journey begins not with a massive, fuel-guzzling rocket, but with a much more refined process. We launch the spacecraft into orbit using a traditional rocket or, perhaps in the future, a space elevator. After reaching the required altitude, the spacecraft would dock with the first component of the magnetic highway, the launch station. No longer burdened by the need for massive fuel reserves, the spacecraft is now powered by magnetic acceleration, gliding seamlessly into the first electromagnetic ring. This is where the magic happens, the first step on an extraordinary voyage to Mars: acceleration through magnetic rings. As the spacecraft enters the first ring, it's immediately accelerated by electromagnetic pulses, much like a maglev train speeding down tracks. Each ring in the system gives the spacecraft a boost, a little more speed, a little more momentum. Unlike the sudden G-forces of chemical propulsion, the acceleration here is gradual, gentle, and smooth. The spacecraft ES onboard systems adjust in real time to ensure that the speed buildup is safe and comfortable for the crew aboard. Every pulse of energy carefully designed to keep the spacecraft on track for its interplanetary journey. With each boost, the spacecraft accelerates faster than the rockets of today, shaving months off the travel time to Mars. What once took 6 to 9 months could now take just weeks, even days, to reach the red planet. Course correction and AI navigation. Space travel is never predictable. The craft must constantly adjust its course to ensure it remains perfectly aligned with the electromagnetic rings. This is where advanced AI navigation comes in. The AI continually calculates the spacecraft's trajectory, and if needed, it adjusts the spacecraft's path using tiny, autonomous thrusters. These precision thrusters ensure that the craft never strays from its path, no matter how unpredictable space may seem. With real-time course corrections and advanced sensors, this system minimizes human error and ensures that every mission stays on target, an incredible leap forward in autonomous space travel. Deceleration at Mars. As the spacecraft nears Mars, there's no need for traditional braking. Instead, the magnetic highway introduces a series of deceleration rings that slow the spacecraft using a controlled reverse magnetic force. The same force that propelled it forward now works to gently bring it to a safe and precise stop. The craft's final approach is calculated with pinpoint accuracy, ensuring that it either docks with a Mars orbiting station or performs a planetary landing on the Martian surface, where humans and cargo alike can begin the next chapter of exploration. The challenges and solutions. Power supply. How do we generate enough energy? To keep these massive rings operational, we need enormous energy. It's a monumental task, but it's possible. The solution? Space-based solar power stations or even nuclear fusion reactors could be deployed to provide the required energy. With constant access to solar energy in the vacuum of space, we could generate enough power to accelerate spacecraft across vast distances without relying on fuel-intensive methods like chemical propulsion. Precise targeting. What if the spacecraft misses the rings? Even with AI-powered navigation, human error is a real concern. But automated thrusters and the AI course correction system would prevent any catastrophic misses. If the spacecraft veers off course, onboard systems can adjust, bringing it back on track in a matter of seconds. Precision is the name of the game. These systems would work together to ensure that no matter how far the spacecraft travels, it remains on course for its destination. Cost. Wouldn't this be too expensive? Building this infrastructure will be a monumental task, but it's possible. It would start with a test system around Earth, then gradually expand to include the Moon-Earth system before eventually reaching Mars. The real beauty of this system lies in the phased approach. Asteroid mining could provide the materials needed for building the rings in space. This allows us to cut down on costs by sourcing materials from outside Earth, dramatically reducing the need for expensive Earth-based mining. Human safety. Can humans withstand high-speed travel? The key here is gradual acceleration. Unlike the extreme G-forces experienced by rockets, the magnetic highway uses a gentle and controlled process to gradually build speed, ensuring the spacecraft crew remains safe and comfortable throughout the journey. Additionally, the spacecraft would be equipped with advanced radiation shielding and an artificial gravity system to mitigate the risks of space travel, ensuring human safety remains the top priority. The magnetic highway doesn't end with Mars. This revolutionary concept is the first step in a massive interplanetary transportation network. Beyond Mars, the system could eventually reach the outer planets, Jupiter, Saturn, and even the gas giants. We could create permanent colonies on moons like Europa or Titan, turning them into hubs of human civilization, enabling us to establish outposts on distant worlds. With this technology, Interplanetary travel could be as common as flying between countries today. A highway in space would make space exploration and settlement a reality. What if, eventually, we could even leave the solar system? The possibilities are endless, as long as humanity keeps pushing the boundaries of what's possible. The magnetic highway to Mars is more than a vision. It's a game changer for space travel, a revolutionary system that solves the most pressing issues of speed, cost, and sustainability. Could this be the key to humanity becoming a true interplanetary species? Could we colonize other planets, travel to distant worlds, and unlock the mysteries of the universe faster than we ever imagined? Subscribe for more mind-blowing space concepts, and join the conversation about the future of space travel. Let's explore the stars together.